Let's go to another example of integrating cos power 3 with respect to x. Previously, I was using small letter integrate. Now I'm going to use capital letter integrate, which is actually more appropriate. So after typing in capital I integrate, I'll press the left square bracket followed by cos x raised to the power of 3. So I'll type cos with x in the bracket, then press shift caret to generate the power placeholder. Key in 3, use my right arrow key to move to the right, separate cos power 3 by a comma, type x to indicate x is the symbol of the variable. Then I'll press right bracket key. Once I have pressed right bracket key, the integration is automatically converted into a mathematical symbol. So that is the form of the integration obtained exactly as if you would to use the icon on the panel here. Anyway, after we have correctly keying in the integrand function and the instructions to perform the indefinite integral, we press shift enter to see if the result obtained are the same. Here you find that the results given by Wolfram alpha are not exactly the same as the one obtained using the analytical method as shown on the left hand side of the PowerPoint in example 11. However, I want to assure you that the expressions given by Wolfram alpha is actually identical to the expressions in example 11. How would you be able to show that the expression on the right and the expression on the left on the screen are the same? To show that the expressions obtained from Wolfram alpha and the expressions given by example 11 through the analytical expression are identical, I'm going to ask the Wolfram alpha to simplify the expressions from example 11 using a function called simplify. Here, I'm going to type in the expressions in the example 11 in the PowerPoint. 1/3 multiplied with cos of x raised to the power of 2 multiplied with sine of x, close the bracket, add 2/3 sine of x. So that is the expression that appears in the PowerPoint on the left hand side for example 11. So when I press the button using shift enter, I expect the Wolfram alpha to give me an simplification of this expression. Wait for a while, I got 3 different results. These are the results of simplifications of the expressions in example 11. And one of the example here, the third output in the results is exactly the same as the result provided by the output of the Wolfram alpha when it integrates cos power 3. So I have just shown you that these expressions from the PowerPoint expression in example 11 is identical to the output of the integrations of cos cube provided by Wolfram alpha. Therefore, even though the results from Wolfram alpha is slightly different from the form of trigonometric functions produced by example 11 in the PowerPoint, they are indeed identical to each other. This is how you can use the simplify functions to simplify an complicated trigonometric function to a less complicated one, such as the expression here. As a conclusion to this video, we have discussed the applications of Wolfram alpha to solve the analytical integration for example 11 discussed in module 2. We have also shown how Wolfram alpha can be used to simplify and check the trigonometric function encountered in this example. In particular, we have demonstrated how Wolfram alpha can be used to simplify a rather complicated trigonometric function to a simpler expression.